or HTR methods cannot get a good performance in this kind of degraded documents. So what we have done in the team to resolve this problem, so we have proposed the UGAN model. It is the UGAN for document enhancement model. This model is based in generative adversarial networks, and the goal is to generate an enhanced version of the document given a degraded version. So what is amazing in the GAN architecture, that when training the GAN, there is a minimax game between the generator and the discriminator. From one part, the generator will try to generate the most readable or the best quality of image to fool the discriminator. And from the other side, the discriminator will try to improve his discriminative power to detect fake images that are coming from the generator. In terms of loss function, we have used the classical adversarial loss, and we have added a regularization term, which is just a binary cross-entropy between the generated image and the ground truth image to improve the result of the generation. Here we show a result of our method of the GAN. It is the last image. So the input is degraded, a degraded image. And as you see here, we are able with our model to remove the noise while keeping the text in the image. And we have compared our model to different state-of-the-art methods, and we have very good results that are very comparable to the ground truth image. Okay, so with deep learning, we had improved the performance of document recognition, but the problem of deep learning that we need a huge quantity of data for training the model. So what we can do in the cases where we don't have many labeled data. This is the case that we have faced in the Decrypt project in collaboration of the Computer Vision Center of Barcelona in Spain. And in this project, we have worked on ciphers documents. So cipher documents represent 1% of document in archives. Ciphers are composed of crypted symbols. And the goal of this project is to develop resources and tools for automatic decryption of ciphered documents. The problem in this project that we don't have many labeled data in our case. So what we have doing to resolve this problem? So we have proposed a model based on few-shot learning. So this is a model, it's a neural network, which is composed of an attention mechanism combined with the region proposal network. The goal of this model is to spot the different occurrence of a symbol within aligned images. The advantage of this model is it is able to be learned on an alphabet and can be after that tested on the other alphabet that he don't see in the training stage. Just we need one or few shots of each symbol. A question that we can ask, do we need when we work on historical document to recognize the whole document? The response is no. For some application, like document indexing and retrieval or document categorization, we need just to find some instance of a query word in the document without fully recognizing it. This kind of techniques is called keyword spotting. And here, in the Doc Preserve project that we have conducted in collaboration of Belsking Institute in Sweden, we have working on historical document, keyword spotting of historical documents. And here we have used a transformer architecture composed by an encoder-decoder. So we have a first processing stage based on self-supervised learning, where we will learn the model in a mask and predict pretext task. So we will mask some parts of the document and we learn the transformer to predict the masked parts. So here the model will learn a useful representation of the image writing. After this first stage, we have a downstream stage where we take only the encoder and we fine-tune the encoder in the supervised learning fashion. The model here will learn to measure, to predict a similarity distance between the pair of words. Another question is, recognition is enough when we deal with handwriting documents or historical documents? The response is no. For some application, we need to go beyond the recognition and we need to understand the content of the documents. Here, an example of a project that we have conducted with InstaDeep in Tunisia. The project is named IntelliDoc, and the goal here, we have a collection of marriage records, historical marriage records, and we need to extract some named entity from these records. The named entity can be the name of persons, the birth date, or locations. Okay? So in the state of the art, the traditional way to deal with like problem is to process in two stages. The first stage we use OCR or HTR, it's a recognition engine, to convert the image to text, and after we apply natural language processing techniques to extract named entity. The problem of this kind of approach that the errors that we get in the OCR stage will affect the NLP stage. So what we have proposed is an architecture based on transformer model, and the originality in our work is we conduct the two tasks in the same time. So we use a joint learning, so our model will output the transcription of the text and the different tags of the named entity. Also in this model, the input is a paragraph, is a page level, so we don't need to process with a line segmentation stage. So it is very beneficial because we will have more contextual information for the named entity recognition stage. This is just some description of our works. These works are conducted with many collaborators. I want to thank my PhD student, my collaborator also. Thank you for your attention. You have here all my contact information. Don't hesitate to contact me if you want to collaborate in this kind of project. Thank you.
No, that's fine. Afterwards, if anyone has questions, you can ask Yusri at the end of the session. Thank you so much, Yusri, for sharing your powerful and impactful work with us today. Next, we're going to be hearing from our runner-up, Funzo Mamba. They've sent in a video.
Oh, started. Good day, everyone. My name is Funzo Mamba, and I'm from South Africa. representing Sign to All team. First of all, I would like to thank the Deep Learning Indaba for this recognition and for providing a space where anyone across Africa can innovate and dream big. Sign to All is a team of 3 young women, Fubuko Matebula, myself, and Charlotte Nisi. Our journey with Sign to All started in 2023 during the AI and Data Science Bootcamp for Women in South Africa. As part of our final project, we had to put our new skills into practice. While brainstorming ideas, Charlotte suggested a sign language translator, and Fubuko shared her experience of having close friends who use sign language. She spoke about the daily struggle her friend faced from school to public service because of communication barriers. That conversation touched all of us and motivated us to build something helpful, a sign language translator. We started small, focusing only on the South African Sign Language alphabet. We did not have many resources and much expertise, but our passion carried us forward. To our surprise, the project was recognized at the bootcamp with Best Presentation and Most Innovative Solution Award. That moment gave us confidence that our idea could grow into something really. The importance of this mission became even clearer in 2023 when South African Sign Language was officially recognized as the 12th national language. This was a historic milestone, a moment of pride for the deaf community and for the country as a whole. But recognition on paper is not enough. The daily reality is that many deaf South Africans are still excluded from jobs and from meaningful participation in society. Many deaf people struggle to communicate with doctors because not all facilities have interpreters. According to the World Report on Hearing 2022, there are about 4 million South Africans with hearing disability, but fewer than 600,000 people actively use South African Sign Language. This shows just how many people are still left behind in communication. For us, this was a call for action. We believe that if the South African Sign Language is now officially recognized, then it is our responsibility to create tools that make the recognition really in practice. That is why Sign to All matters. Our dream is to transform what started as a small alphabet translator into a real-time communication tool that could be used in classrooms, hospital, workplace, and everyday interaction. A tool that can help bridge the gap between the deaf and the hearing community, making inclusivity not just a slogan, but a reality. This award inspires us to make building. It reminds us that ideas born in Africa by young women like us can grow into technologies that can solve African problems in meaningful ways. This recognition is not the end of our journey, it is the beginning, and we are committed to continue the work of making communication accessible for all. Thank you.